Hey ladies, so this is section 6.4. Here we're going to be solving trigonometric equations using identities, so it's kind of a nice little wrap-up, I guess, section that we've done for this unit. So I'm going to kind of apply everything that we just learned, and we're going to apply it to this. So when we're solving a trigonometric equation, this means to find out the possible value or angle values that make the equation true. You've probably written that down probably at least 5 or 6 times by now, so make sure that you have to find those values where it makes the equation true within the given or stated restricted domain. And when you're not given it, remember to provide a general solution. If they give you a restriction, you just have to find those values in between there. But if it's if they don't list one or they ask for a general solution, then that is when you're going to make your general solution. Okay, so some different strategies that we'll look at when we're solving these trigonometric equations. Your first one there, or I guess your first strategy, we can isolate the trigonometric ratio. So in this example here, we have 2 sine x is equal to 1, and we want to get sine of x by itself, so we divide each side by 2, and what we find that sine of x is equal to 1/2. Then from there you could solve to find x and either use your unit circle, or what you also could do is you'd have x is equal to sine inverse of 1/2, and you'd find that first value there about when sine of x is equal to 1/2. So both methods would give you the right answer. You guys should already know that. You guys worked through that through multiple chapters, so hopefully that should work there for this first strategy. So your second one, here we need to factor and then set each factor equal to 0. So this is especially when we're dealing with, say, quadratics. Here we have sine squared of x minus 1 is equal to 0. This one is a nice little case here. This is a difference of squares, so we have sine of x minus 1 times sine of x plus 1, that is equal to 0. So then what you guys will do here, if it'll write, so we'll write the first one, so we have sine of x minus 1 is equal to 0. Then we have sine of x plus 1 is equal to 0. And then what we'd find is sine of x is equal to either 1 or negative 1. And here I just rewrote it as a general all-in-one where we have sine of x is equal to plus or minus 1. Then from there, you could solve for x. Ask yourself, when is sine of x equal to either positive 1 or negative 1? And that there is either in degrees, it'd be 90 and 270 if you had that restriction of just the one rotation of the unit circle. Or it could also be pi over 2 and 3 pi over 2. Okay? So I'm going to scroll on down here. So our third strategy here is that we could simplify the given equation, or we could change the given equation to one common ratio by using the identities that we have studied in this chapter study, section 6.3. So that was what we literally just looked at. And that's also, I guess, also previous stuff too. So 6.1, we've studied it through this whole chapter. So once we've done that, then just solve. So from there, as a quick note, to check the trigonometric solution, we need to verify it by graphing. So make sure that the graphs, they should look they should look the same, but there might be some cases where by verifying it by graphing might not work out, but in almost all cases it should work out by graphing it using your calculators. And we also need to check that the solutions for equations do not include the non-permissible values from the original equation. So if you're manipulating it, make sure you have to state those restricted values, and that they're not included in your end solution when you get through it all. Okay? So now let's do some examples, and we'll put these strategies to use, okay? So for this first example here, we need to solve each equation algebraically over the domain 0 is less than or equal to x, which is less than 2 pi. So really nice here, they give us what values we're going to be using. We're going to be dealing with radians. And we have this restriction that it has to be within one rotation of the unit circle, or 0 to 2 pi. Okay? So to start off here, we have sine of 2x is plus sine x is equal to 0. Right now, looking at this, we can't simplify this a whole lot, or we can't really do anything with it. So what we need to do is we need to change either one of these into an equivalent form. So this is going back to what we did yesterday, or say section 6.2. So let's change up this here, sine of 2x. If you guys go to your cheat sheet, you guys will find that sine of 2x is equal to 2 sine of x times cosine of x, and then we have plus sine of x is equal to 0. Okay, so let's rewrite that into a different form, and there was only the one identity that we could use, so sine of 2x is equal to 2 times sine of x times cosine of x. And then from here, what we're going to do is we have that common factor of sine of x. So let's pull that out. So here we have sine of x times 2 cosine of x plus 1. So remember, you just divide it, so there'll be 2 cosine of x plus sine divided by sine is just 1. And that is all equal to 0. Then you have to ask yourself, okay, well, can I do anything else with this? I don't think you can. I think it's pretty good for where we're at. So then we're going to use that second strategy where we're going to set each of these factors to 0. So our first one here is that we have sine of x is equal to 0, and we have 2 times cosine of x plus 1 is equal to 0. Okay, so dealing with this first one here, we have sine of x is equal to 0. Using your unit circle, using your reference angles, or that cheat sheet that I gave you guys, when does sine of x equal to 0? And within our restriction there, for 0 to 2 pi, and what we'll find out, if you guys use your unit circle there, you'll find that x will equal 0 at 0 and pi when we have sine of x. Okay, so now we'll look at our second factor here. So we have 2 times cosine of x plus 1 is equal to 0. So to do this, we'll be using that first strategy. We need to isolate the trigonometric ratio. So first we're going to subtract each side by 1. So what we're left with is 2 cosine of x is equal to negative 1. Then we'll continue to isolate that by dividing each side by 2. And we have that cosine of x is equal to negative 1/2. Then from there you can ask yourself, okay, well, what values of x would give me negative 1/2 when I put that value in for x? And using your unit circle, you guys will find out that any values would be 2 pi over 3 and 4 pi over 3. So using your, either you could use your reference angle and then use your cast rule. So when does cosine of x, when is that a negative value? And then, or you could also use your unit circle, which you guys won't have for your final, but you guys could use that for now. Okay. So now that we factor this, it's all great, good to go. Let's do it. I guess we can combine what we've, what we've learned for x. So what we can say is that x is equal to 0, pi, 2 pi over 3, and 4 pi over 3. Okay. So any one of those values is when you'll find that your left-hand side will equal 0. Okay. So that one's good to go. Here we used 2 of our strategies. Actually, we used all 3 of them, so that was kind of nice. So they're pretty helpful strategies, so just go through the list, see which one you can do, and go from there. Okay, so here we have 6 sine squared of x is equal to cosine of x plus 4. Alright, so where do we start here, ladies? Well, personally what I would like to do is let's get everything on one side here. So I'm going to move our right-hand side here to the other side. So we have 6 sine squared of x minus cosine of x minus 4 is equal to 0. Then you can ask yourself, well, is there anything that I can factor? Is there anything that I can simplify? Well, at this point, there really isn't anything. So my next guess, I guess you could say, would be let's use one of our Denny's and let's change something here so that way we can either take out a factor or do something with it. So first of all, let's look at sine squared of x. We know that using our Pythagorean identity, we can rewrite sine squared of x as 6 times, and that'd be 1 minus cosine squared of x. And then we'll just leave this here for now. So we have negative minus cosine of x minus 4 is equal to 0. Okay. Then we can distribute that 6 there. We'll simplify this a little bit more. So we have 6 minus 6 cosine squared of x minus cosine of x minus 4 is equal to 0. Combine like terms. You guys see where this is headed? We're going to get to some factoring in a bit. Ooh, fun stuff. Okay, so we have negative 6 cosine squared x minus cosine of x. 6 minus 4 is 2, and that is all equal to 0. Okay, so from there what we're going to do here is that we are going to factor this, like I just said. So here we'll be looking at, well, I guess in this case will be decomposition, because we have our a value there is not equal to 1. So what we'll be looking at is we have a product of the a value times your c value, so be negative 12. And it should have a sum of negative 1. And if you guys think about it, so what multiplies together to give you negative 12, and what if I added those same two numbers, what would give me negative 1? If you guys think, you guys can go through your factor tree, or if you guys can think of that off the top of your head. Here we have negative 4 and 3. So negative 4 times 3 is negative 12. And then adding the two together, we get negative 1. So those are two factors there that we can use to rewrite to solve this question. So I'm just going to continue writing. I'm going to write down here, ladies. So hopefully you guys should have room. Like I said, I have monster writing, especially with the stylus. Alright, so we're going to rewrite this factor right here with our negative 4 and 3. So we have negative 6 cosine squared of x minus 4 cosine of x plus 3 cosine of x plus 2 is equal to 0. So if you guys remember decomposition, we're going to group these two factors together and these two over here. Okay, so here what do we have in common? We have a negative 2 cosine of x. And what we're left with when we pull that out, we have 3 cosine of x plus 2. And here we don't actually have anything in common that we can pull out, so we'll just have a plus, or you can do positive 1 if you guys want to see that. And we have 3 cosine of x plus 2 is equal to 0. Then we can pull out a common factor of 3 cosine x plus 2. And what we're left with there is negative 2 cosine of x plus 1. And those are both equal to 0. Okay. So now we're going to use that strategy. We're going to set each of those factors equal to 0. So we have 3 cosine of x plus 2 is equal to 0. And negative 2 cosine of x plus 1 is equal to 0. Then from there we'll solve each one of those. Here we'll subtract 2 to the other side. So we have 3 cosine of x is equal to negative 2. Divide by 3, we have cosine of x is equal to negative 2 over 3. Okay. For our second one here, we have negative 2 cosine of x. We're going to move that 1 to the other side, so we have negative 1. Then divide by negative 2, we have cosine of x is equal to positive 1 over 2. Okay, so to finish this question, I'm going to, let's switch over to video number 2. I tried doing this all in that time frame, and it didn't happen, so let's switch over to video number 2.